you. Turn it off in there. Thank you very much. So my name is Luca. I work as a software engineer at Microsoft in the Azure organization.
I am Zbyszek. I work in Red Hat in the same position. Well, not Azure.
Not on Azure, I hope. So we're going to talk to you about the systemd state of the project for the last year. We did the same talk at ASG last year, and people liked it. So we're going to give you a generic update on the health of the project, the status, development, maintainership, and so on for the past year or so. So first of all, systemd is managed by SPI, software in the public interest, at least in the sense of financial and legal matters. We are very thankful to SPI for their work by focusing on all the legal contract signing and financial matters for us. They let us developers do what we do best, release version of systemd that delete your home directories. Every year we send a report to SPI. This is what it says there. Our numbers keep going up, which usually is a good thing. We have more commits than last year, more contributors than last year. That's all great. We had 419 individual contributors last year, which again is pretty good, if you ask me. We also try to do 2 to 4 major releases per year. This year we were a bit slower. We'll see in the next slide about that. But we also have stable releases, more or less once a month. These are maintained depending on who does the work, who needs it for what use case. For example, the 252 version had 39 releases over 3 years. I maintained that. I did all that work basically for the benefit of Debian 12, the Debian stable project, which used this branch. So just by counting the number of commits that affected source components, so excluding docs, tests, and whatnot, there were about 1,000 backports. So more or less 1,000 bug fixes, which is pretty nice. So in terms of maintenance of the project, we have 6 core maintainers, 1 for Meta, 2 for Microsoft, 2 from Red Hat, and 1 unaffiliated. But of course, we have many, many, many more maintainers than that. We have many more contributors. We have very important contributions from SUSE, from Canonical, and many other companies and projects, too many to keep track of. Finally, almost every year we try to participate in outreach. I say try because we might not have budget or we might not find an intern. So for this year we had Zico, who was our outreach intern for the summer, and what we got from that project was new service debugging capabilities. So if you do systemd analyze unit shell, for example, if you run a unit with all the sandboxing, that will drop you into a shell in that sandboxing. If a unit uses sandboxing, images, seccomp, whatever, that shell will run under those same constraints, so you can debug it. You can also have the unit GDB command, which does the same, but for GDB instead of the shell. And this is all merged and part of 258. And for the next PR that is being reviewed right now, we'll also add the capability to do start GDB or something like that, that allows you to start a new unit entirely under GDB, so that you can debug not only the startup phase of your unit, which is very often very error-prone and can cause many issues, and it's difficult to debug, but also it allows you to debug the systemd internal code that sets up all the sandboxing, which also can be quite complicated if you have a seccomp, mountain spaces, images. That code is quite complex. Sometimes you need to debug it, and with this feature, you'll be able to. So yeah, we thank Zico for his work, and Outreach for the internship, and Microsoft for funding the internship.
So Luca mentioned that we do stable releases, and my expectations was that the number of stable releases would keep going up. But as you can see, well, we started in 2019, so the number is not fully valid, but then it kept going up. We had more than 60 last year, and this year we are at half of that, and with linear estimation we are not going to make, or we are going to end up around 50 to the end of the year. I'm not sure why that is. Maybe we backport less things, or focus shifted to other things, or something like that. If we look at the number of commits over time, there is some slowdown, and here on the right, like summer of this year, I think that this is because we said that we must release 258 and we will not do major features in 258 until the release happens. And there was lots of crying, and apparently, well, I mean, to fix things, you usually need one commit or two, and then you get much lower commit count overall. So I think that in this gap that is visible, the actual quality of the code was going up, but just the statistics were not improving. Another way to look at this is this graph. I don't know, it's clear. This is each year goes from left to right, and then is in a different color, and the colors start up light and go dark. This graph includes the years of, well, starting in 2008, where systemd was still not a thing, because the UDEV, full UDEV history is included in the systemd repository, because there was a merge of UDEV code at some point. So, well, you can see that in general, every year we did more commits, but if we go to the last 5 years, the last 6 years, 2025 is the short one in the middle, and you can see that, well, that the pace is a bit lower. It has stopped going up, at least, and the slowdown for the 258 release is clearly visible, and then the pace picks up again. It turns to the previous linear estimate. And another thing that I wanted to mention here that I find is interesting is that COVID is essentially not visible at all. Maybe like in the middle line there you see some slowdown in the summer, but that's not clear if this is even related to COVID. Yes.
Yep, so the question was asked before in one of the previous talks about our continuous integration status. I had this slide last year as well, modified. I won't go through every single thing, but the thing I will mention is that last year I explicitly said our non-x86 story was a bit weak. Basically, we had package builds and unit tests for two distributions, and that was it. This year is much better. We are improving a lot. So thanks to GitHub and Microsoft, we have an ARM64 GitHub runner. So now we are doing full builds and image builds, and we're running part of the integration test suites. Now, as Dan said in the previous talk, a chunk of the integration suite runs in a VM. So because ARM64 does not have currently nested virtualization acceleration, we don't run that. So we run maybe 70% of the integration test on ARM64. I believe that it might or might not be being worked on. So once Azure gets ARM64 acceleration for ARM nested VMs, then we will get full test coverage parity between ARM and x86, which is going to be great, but not there yet. Other thing we have changed is that thanks to IBM, we have GitHub runners for S390X and PPC64. So these are LXD containers. So we have full build, package builds, and macrosio image builds, and unit tests. We do not have integration test suites yet because same reason for the VMs, is too slow, but also for the containers, the current configuration does not allow privileged containers in the guest, so we cannot run and spawn. We have asked for this, so hopefully that will be implemented, and if so, we'll have the parity with ARM64.
The maintenance of this infrastructure, they are working with us, and they are making a huge effort to solve those issues.
Yes, we are very grateful for their work. They helped us fix their configuration and so on. When we found issues, they're being really amazing. And yeah, we get this for free. So again, thanks IBM for this. The other thing I want to mention is that it's very recent. We now have packages built from Git main available. They are rebuilt and republished every time we merge or push something to main. This is done on the SUSE open build service, so thanks SUSE for maintaining that and the public instance. We build packages for Debian, Ubuntu, Fedora, Arch, SUSE, x86, and ARM64. So we will have a bit more information about this in a later talk about dogfooding, but anybody who wants to try the very latest systemd, whether in their CI systems, on their developer laptops or whatever, they can just use these repositories. The packages are the same as you would get in your distro, just built from Git main. So you can downgrade, upgrade, and everything. So yeah, that is available and linked there. Now, next, previous years we did contracting work. We keep doing that. So, thanks to the Sovereign Tech Agency, previously Sovereign Tech Fund from Germany, they fund us to do various things. First of all, there's I believe a German company called Neighborhoody who works on various things that are maybe not our core focus, but they can help with to take a load off our shoulders. For example, they are working right now to convert our documentation from DocBook, I believe, which is all the XML stuff which is deprecated, and into Sphinx. And you want to mention something about that?
I mean, the contract work is mostly finished, but we didn't really integrate this properly in systemd. We need to actually do it, but and I guess it's on me, and I really plan to do it.
Yes. Yeah, thank you for that. And again, thanks to Neighborhood for that. The other thing we have is security bounty program on Yes We Hack. Again, funded by the STA, so thank you, the STA and the German taxpayers, I suppose, for that. Unfortunately, we are pretty much seeing the same thing that many other open source projects see. There is a huge amount of AI-generated, not good quality reports that unfortunately takes like 3 seconds for a submitter to do, and then takes me 1 hour to actually do. Actually, this sounds not right, but maybe I got something wrong. I should double check, and then I check it, and yeah, it's absolutely nonsense. But I spent 1 hour, they spent 1 second to submit it, and it's not useful for anybody. So this is a problem. I don't know how we're going to solve it, to be honest, but it affects us like others. Other thing we're going to do again with the Sovereign Tech Agency, we were funded for some work last year on the integration test suite and MKOSI. This year we got a new project approved. So this is in collaboration with several individual GNOME developers. So we have these high-level 5 milestones that they will be working on from pretty much now. This was announced last week or so, and for the rest of this year and part of next year. So basically, it's all around GNOME integration and integration with the desktop environments. Some work there was started in the previous few years, and is going to be completed. I won't go through all the individual details, but we will see pull requests coming up soon.
The 258 was a bit of a disaster, as was mentioned. I mean, yes, we had lots of features, but we were slow in making. And we tried. This huge update caused many failures in CI testing in distributions. And for example, in Fedora, even though systemd was being built, like the RC releases, it was not actually delivered to users because there was always something that was failing. And when we fixed one thing, another thing popped up in one of the 15 ways that we deploy things. And in general, the clear conclusion is that we must release more regularly with smaller scope, like follow a bit of the kernel model, and we have definitely plans to have a fixed release cadence. What do we want to say here? In preparation for 259, we already have 300 commits, but also 108 items in the milestone. So if we, this is a lot, and if we really want to make another release before the end of the year, then we need to make some tough decisions, and those decisions hopefully will be made. So be prepared.
Yeah. So the agreement is we try and stick to this. So come hell or high water, on the morning of the November 17, I will tag RC1. Who's in is in, who's out is out, and we'll stick to the schedule. At least that's the intention, of course, all the best intention and so on. Right. So finally, let's end last few minutes with a release highlights from the past couple of releases. Just going over very quickly, we did a bunch of work in 12.7 for UKIs. So one of the main problems with UKIs, unified kernel images, single image, single immutable blob. So if you want to extend them or have some different runtime options, well, that's a bit hard. You have to use add-ons and so on. So Leonard came up with the idea of having profiles. So in a single UKI, you can now have multiple profiles. For example, you can have your main normal kernel command line, and you can have a debug one. So if, in case your system is hosted, you can, when you go in systemd boot, it will automatically parse this and show you, actually, you can boot with the debug profile, and we'll set debug and whatever else on the kernel command line. Another thing is device tree. So in the x86 world, we are lucky with ACPI and so on. Other architectures, not so much. So one big problem is that to boot a specific piece of firmware plus hardware, you need a and kernel, you need a very specific device tree. And it's basically a thing that describes the hardware. And so far, the only answer was where you do a kernel image build for each of your different devices and firmware and kernel combinations, which is not great. Now we have this automated matching. So in your UKI, you can add as many device tree as you want. Systemd stub at runtime, we figure out which one is the right one to use based on whether there's some hardware IDs and there via SM BIOS, or also if the firmware provides a device tree, it will look for a matching pattern there, and it will pick the right one for you. So hopefully this makes UKIs much simpler to use, especially for distributors, image builders, especially for things like these new ARM laptops. I think the Canonical folks are using a variation of this for their Ubuntu images for ARM, which is great. Other thing, we have add-ons for UKIs, already mentioned. You can have a kernel command add-on. Now you can have initrds and microcode too. So if you have an add-on, which again is a P binary, which is signed, and you put it in the ESP, systemd stub will pick it up, and if it's an initrd, for example, we just concatenate the initrd contained UKI and the add-on one when you boots. Then we have a bunch of great improvements for sandboxing. We have many namespaces options, systemd, user mount, and so on. We so far lack the PID namespacing. This was added by Dan, I believe. And so basically it allows your systemd service to be a full container manager where you can delegate the stuff and then you run it in a PID namespace, and yeah, it's like a full podman or so. Last thing we added, I believe it was my colleague from Microsoft, Anders, ID map mount. So I won't go into this, is very complex, but basically it allows you to make state directories like var, lib, service foo visible to an unprivileged service that runs with a dynamic user as if it owned the directory. The files, directories on the disk stay the same, owned by root, but the service will see they're owned by the dynamic user it is currently running under, and all in memory without changing the disk. Finally, to proceed with the varlinkification of the universe that Leonard is pursuing, we wanted to make available varlink APIs, just like we have the dbus APIs in libsystemd. Of course, varlink requires JSON, so we have both varlink and JSON available in libsystemd. 258, first of all, cgroup1 is gone. Kaput. It's a next feature. It has met its maker. So no build options, no command line options, no option of any kind. It's gone. If you still run with cgroup1, sorry, you need to really get a new kernel. Then verification is progressing. We've got new varlink API and a bunch of services. Credential usage also keeps expanding. User units can now use encrypted credentials. This was a very much requested feature in the past. I've added a bunch of offline, I think, signing support of various tools. In the dogfooding talk, I'll go over this more details. And again, more sandboxing. We just saw a talk about BPF delegation from Matteo. Again, Meta did more work to delegate even more user namespace and stuff. And my colleague Anders again did quotas for state directory. So now you can have a system service and you can assign a quota so that if you have state directory equal foo, it cannot just override and run out your old disk on var lib foo. You can have a quota and it will stay within the limit. And finally, Leonard added some very nice concurrency limit on slice. It's a very simple feature, but it's so powerful. It allows you basically to do job queuing. You have a slice foo and you say this can have only 10 units active at the same time. If you have 20 that get activated, the last 10 will queue and they will wait for the previous one to finish. And yeah, so Leonard did some amazing Mastodon series for both. I link them here where he describes all the many more features that we have, because we have a lot of features. And yeah, those posts go in great details and it's a great way to evangelize about this. And we are now done, just in time. Excellent. So for the next thing, we will have a round table with the maintainers. So we will have a quick break. And
we have time for 2 questions, I think.
we have time for, well, we have a round table for questions, but if people want to ask a question now, we have 2 minutes. Otherwise, we can prepare for the next. Yes, question over there. Can someone please? Thank you.
Regarding the non-x86 testing, there is TCG and QEMU, and you don't need KVM to run full system test in QEMU from any to any platform.
Yeah, we know it's very slow. Like, I've run them.
I know it's slow,
Yeah.
but you know.
I know.
Like,
yeah. Swing and roundabouts. Yes, no, I've run them. I ran them on both PPC and ARM64. They work. It took like 4 hours or something. So, unfortunately, we cannot enable it until we have acceleration. But yeah, the TCG emulation is available and it does work. So you can run them locally. So locally, you can do ARM64 integration test, and you can, if you can wait. Yes. Someone before mentioned about what they could do to help. As Dan said, GitHub runners. If you have GitHub runners, GitHub lets you integrate with other people's runners. If you have runners that you can contribute to the project, that's the perfect interface, because then you manage the machines and we get the jobs queued there. That would be the perfect thing for our project. Yeah. Any other question, comment? All right. Then I think we can break for 5 minutes and then for the next. Thank you. Thank you. Oh, sorry, that's yours.